So there is a very high chance that the people in a specific switch will not even exhaust it. Let me say you are deploying to based on the departments in your organization. You have the accounting, you have accounting, you have the maybe logistics, you have HR, and then you design your network in a way that you give each department one switch. And in each department, you may have maybe about 10 people, 15 people. But a switch port can accommodate at least layer 2 switch can accommodate at least 24 devices in it, right? So if you have only about 10 people connected to one switch, and then another department may have only 5, but for each of them, you need to be dedicating one switch. Number one is that it is going to make your network very cumbersome, very big for no reason. And number two, costing money. For each of those switches you buy, it costs you money to buy one switch, license it, support it, and all that. So it increases what we call the administrative overhead in the environment. So is there a way that we can actually reduce costs, reduce the size of the network, increase performance, as well as security? Most especially when we talk about the cost part of it, right? So that is where VLAN comes in, virtual LAN. It's just a way you break a single switch into multiple switches. You have a single switch, you break it into multiple switches. So now one switch is seeing itself as multiple switches. So let's proceed. So we said that a VLAN is a technology used to segment devices connected on same switch into different broadcast domains. I don't know if we talked about broadcast domain and collision domain in this class, but I'm not sure I'm the one that ran the initial classes. But then there's what we call a broadcast domain, there's what we call a collision domain. By default, all devices connected to a switch belongs to one broadcast domain. What does that mean? If anybody sends a message on that switch, send a broadcast message. A broadcast message is like an announcement, right? It's an announcement that you make. If you start and make an announcement, everybody connected to that switch will receive that message. But then only the person who needs the message or the message is destined to is the person that will respond to your message. So that's what we call a broadcast domain. So by default, everything connected on the switch belongs to one broadcast domain. This is because all the ports by default belong to a single VLAN. By default, we have only one VLAN on the switch, which is VLAN 1. And all the ports, 24 ports, however ports you have on the switch, belong to this VLAN, right? So whatever you are doing, the broadcast domain, all of them are part of that single VLAN, but everybody belongs on that VLAN. But if you introduce multiple VLANs, you are hereby creating a virtual switch. You're breaking down one switch into multiple switches, thereby breaking the broadcast domain. Because everything on one VLAN belongs to one broadcast domain. So if you introduce multiple VLANs on your switch, you are breaking that broadcast domain into multiple broadcast domains. So that is what the switch does for us. That's what the VLAN does for us, right? And we say it's also implemented to enhance security for easy configuration and implementation. And VLAN is a layer 2 protocol. So it runs on the layer 2 of the OSI model, but it deals with MAC addresses and it's something that we configure on the switch. Like I said, the default VLAN on the switch is VLAN 1. And by default, all the interfaces or ports, however you want to call it, on a switch will belong to VLAN 1. You can create a VLAN with a VLAN ID, but there are specific values or numbers that are accepted to be recognized as a VLAN ID. That is from number 2 to number 1001, and then number 1006 to 4094. This is because Now, VLAN ID 1 is already VLAN 1 on the switch, so you cannot create another VLAN 1. And then we have the other default VLANs on the switch, which is 1002, 1003, 1004, and 1005. Those are default VLANs already existing on the switch, so you cannot create another VLAN that will have that name. You can also assign VLANs a name for easy identification. If, in addition to the IDs that you assign to your VLAN, the Cisco devices allow you to give your VLANs a name. So you can give it HR, give your VLAN, IT, whatever name that you want to give your VLAN when you configure it. It could help you to identify the VLAN when you're doing a troubleshooting or reviewing your configuration, instead of just relying on the VLAN ID. But mostly, you're going to be dealing with the VLAN IDs a lot. So this is how it looks like, right? I have this one switch. This is a 48 port switch, and this is a layer 2 switch. Instead of, usually what we will do is we are going to have 4 switches here. One switch for sales, one switch for accounting, one switch for HR, one switch for IT. And then we will dedicate each of the switches to the department. But if we have a 48 port switch, that is a very large amount of ports for us to just do. We can actually have all of them plugged on the same switch, and then we segment them using VLAN. So VLAN is what we use for segmentation. Also in cybersecurity, when we talk about segmenting your networks and improving your security, VLAN will always crop up a lot. So you can actually dedicate a specific port to be part of a VLAN and then have the department's computers plugged on that VLAN, instead of you having to have individual switches for each of the VLANs. So this is how it will be. As you see here, I have about 12 ports dedicated to each department, and then I assign them VLAN IDs. You see, we have VLAN 20, VLAN 30, VLAN 50, and VLAN 40, and also has a name, sales, HR, accounting, and IT respectively. And all these are on the same switch. So I don't need to have another switch to do that if my users are within this number of ports, or within this number of bits, right? Like we said, by default, computers on different VLANs cannot communicate. The same thing we see when we use multiple switches in our environment. If you plug one network on a switch and another network on the switch, of course, by default, they won't communicate unless there is a router in the middle to route the traffic across. So that still stands with VLAN, because the only difference is that it's just like you creating virtual switches. The only thing is that you're doing it on one switch. So it's still like this diagram I have here now. What this means is that I've broken this single physical switch into 4 virtual switches. So anything that I plug between the VLANs are not going to communicate by default until there is a proper routing done for these VLANs. So to allow communication, proper routing has to be done here for you to allow communication between the VLANs. Now let's look at the why VLAN. Why will organizations spend money doing segmentation? Why are we going to do segmentation? There are definitely 5 main reasons why organizations will spend their time and energy creating VLANs and managing VLANs. Number 1 is for security. You can isolate sensitive departments from general departments. For instance, if you have your HR department that deals with a lot of documents and database of the employees, you don't want them to be in the same network with your guests or your visitors. That is a kind of a security problem, because that means everybody on the network can actually communicate and see what each other is doing. If there is a man in the middle right there, right? But with VLANs, you can isolate your sensitive department from your general department, thereby providing it more security. So we have flexibility. Group users by function instead of physical location. So you can group your users by their roles, by their function, by what they do, or however you want to group them. It gives you the flexibility to design your network in a way that you can identify groups or roles based on the VLANs that they are part of. Then for performance, you see, like I said, VLAN will help you reduce the size of your broadcast domain, because once you create VLANs, you are breaking a broadcast domain into multiple broadcast domains, depending on what you have. So it limits the size of the broadcast domain, thereby reducing also the size of the messages that will be flooded in your environment when there is a broadcast message sent out. So it will limit the amount of traffic that will be flooded, because now the broadcast domain is broken. Not all ports will be receiving all broadcast messages. It's only the ports that are part of that VLAN that will now receive the message. Cost, that one is a no-go area. So you can reduce the need for additional hardware. If you have one switch and you have only a specific number of people, they can accommodate in your single switch. You can just use them on your single switch instead of having to buy multiple switches for each of your departments. Scalability, you can easily add and remove users without having to do physical rewiring or redesigning your network, because you already know the VLAN that they are in. You just have to go and disconnect them from that VLAN. If you need to add them to another VLAN, you go and add them to the other VLAN. So you don't need to do anything extra for you to be able to. You don't even need to change the cable. All you need to do is where they are connected, move it to the VLAN that you want it to be, and voila, they are working. You don't need to move anything as long as you're moving the ports into the right VLAN. So you can easily add or remove users from VLANs without touching the physical wiring of the environment. Ask your questions, please. Ask your questions. If you keep quiet, I'll take it that you're with me. Okay, let's proceed. So let's talk about the interfaces that will come up when you talk about VLAN. There are two main interfaces types or interface types that you will hear when we talk about VLAN. The first one is access ports or access interface, and then we have trunk ports or trunk interfaces. What is different between these two? So we say the access port, these ports that can be assigned in single VLAN, usually connected to end devices. So your computers are connected to interfaces that only understand or carry traffic of a single VLAN. When you plug your computer does not need to know about multiple VLANs that exist in your suite. So the access ports are where we connect your end users, your computers. And then we have the trunk port, is the port that's connected to another switch and can carry multiple VLANs. So when you have multiple interfaces, multiple switches, and you have users plugged on these switches with VLANs also created in these switches, and you want the traffic from one switch to move to the other switch without you wasting individual ports for individual switch, individual VLAN, you can use one port and configure it as a trunk port. The trunk port is able to carry multiple VLANs. So multiple traffic tagged with multiple VLANs can cross the trunk port. That way, the communication is going from, let me say, from this computer in the red zone or red VLAN and going to the computer on the red VLAN on the other switch. You can just go through the trunk port and reach there. Even if it is a inter-VLAN communication, maybe from VLAN green to VLAN red, you see this is multiple VLAN traffic. It can still pass through your trunk interface. But if you do not trunk the interface, that interface will only recognize one VLAN traffic. So that will force you to create multiple interfaces for each VLAN that connects to the switches, which is a waste of ports. Why would I have, like here, I have 4 VLANs here. That means I need to do 4 connection between these switches and make each of them carry individual VLAN traffic. Why will I do that when I can use a single port to achieve the same purpose? All I need to do is dedicate the port as a trunk port, and it will be able to carry the multiple VLAN traffic between the devices. So for access port, remember, it is for end devices, computers that are users, for computers or anything that is not a network device, right? But for a trunk port, the trunk port will be connecting between switches. You have to trunk that so that you can identify multiple VLANs, unless you want to do each interface for each VLAN, which does not scale in today's production environment. Okay, let's proceed to configuration. Configuration is very simple. To set up a VLAN, very simple on your layer 2 suite. So we have this problem here. I wrote down this problem here. We have grade 4 VLAN as follows: sales VLAN, HR, IT, and accounting, and give it these numbers, right? And then assign the port below to the mapped VLANs. Now, remember that what you are assigning to VLAN are the ports. The users will not plug into those ports. Or you can call them ports, you can call them interfaces, whichever one you want. So the ports on the switch is what you are going to assign to the VLAN. By default, all these ports from port 1 to port 24 will belong to VLAN 1. But once you create these VLANs, you will be able to move the VLANs to specific ports. Move the port to a specific VLAN based on your requirements. So here says we can make sales for sales department or sales VLAN. We can make port 1 to port 5 part of this sales VLAN. Then for HR VLAN, we can make port 6 to port 10 part of that. And then for IT, port 11 to port 15. And then accounting, we can do 16 to 20 as part of the accounting VLAN. So when you achieve this, there's a little more to do. Add 2 more switches and connect the trunk as follows. So now we want to add more switches and then replicate the VLANs on all the switches, including the interface assignment. So we're going to do that, and we are going to test the connectivity. But first, we need to subnet. Create 4 subnets out of this and assign a subnet to each department, and then test your connectivity. So let's go ahead and do this test or this exercise. We're going to start creating them. We're going to start with 1 switch and create these VLANs on the switch. Assign these ports, and then we'll continue with the rest of that. Ask your questions, please. Ask your question. Somebody is asking, is this the first class? No, this is not the first class. Let me pull up my packet tracer and we'll get started while you ask your question.
Hello?
Go ahead.
Okay, please, can you take it to the previous slide? I just want to ask a question. The previous slide.
Here you go.
Okay. Now, you were talking about trunk the other time. So we have the yellow line that is connected to the first switch. Is it that the collections of these VLANs, this first switch, the 4 VLANs that we have, we converted to one VLAN? I mean, sorry, one cord that will pass through that yellow indicator that you put there. Is that how it is done?
So the trunk port is just like this is a port you have here. You can see my mouse, right?
Yes.
So this is an interface. This is another interface. We want to connect these 2 switches together, right? So plug a cable here that connects to over here. But the goal is that, remember that these ports by default belongs to VLAN 1. So they will only carry traffic or understand traffic that are tagged for VLAN 1. But our goal is that you see on switch 1 and switch 2, we have multiple VLANs. and we want what do you call it? All these VLANs to be able to move their traffic to the other router, right? Other switch. So if we assign this switch here, this switch port here to only, maybe we go to the configuration and make it to be part of the green VLAN. That means the traffic that will pass through this connectivity in only the traffic of that is tagged for VLAN, for this green VLAN. Any traffic that is tagged with the red VLAN will not be able to pass this connectivity to the switch, because it's going to be tagged at the point where it is leaving the switch. So if this switch if that interface does not understand or allow that VLAN, the traffic will be dropped right there. So the one, wait, let me pull my board. Where is my board? Where is my board? Where is my board? Oh, there it is. Let me find somewhere to plug this. Jose, will this be on YouTube? Yes, the video will be on YouTube later. So let me share my oh, because I mentioned it. Okay. Just a moment. I'm trying to reshare my board right here. Let's take to this. All right, can you see my whiteboard? Please confirm if you can see my whiteboard.
Yes, ma'am.
All right. So let me say I have a switch here. This is one switch. And I have another switch here. These are layer 2 switches. And this switch, I have port. I have port. These are connectivity. I have another port here. And this port here, I've tagged them to belong to VLAN 2. And this port here, I've tagged them to belong to VLAN 3. And this port here, I've tagged them to belong to VLAN 5. And this guy also have similar configuration on the ports. So this guy, I've tagged them to the VLAN 2. These guys, I've tagged them to the VLAN 3. And these guys, I've tagged them to the VLAN 5. So now, let me say computer here. Now we need to make a connectivity. Let's just make this is a normal connectivity we do. Then I have a computer here. Want to talk to a computer here on VLAN 3. This guy wants to talk to this guy here. By default, this port will belong to VLAN 1. So VLAN, the purpose of VLAN is that the traffic is being tagged with a specific ID so that we know the VLAN port where that traffic will be sent to. If this guy belongs to VLAN 3, the traffic will have a header on it. I think it will be on the frame header where you have the VLAN ID in the packet or that shows VLAN 3. So once this guy reaches here, it gets to this interface. This interface will check on the target and see what tag, does this guy have a tag? If he has a tag, what tag is it? You see that it is a VLAN, it's tagged with VLAN 3. This port where you plug here, does this port understand or allow VLAN 3 on it? Remember that this guy by default belongs to VLAN 1. So once the interface on the switch check on the tag and I see that this guy belongs to VLAN 3, but the interface on the router here belongs to VLAN 1, it will drop the traffic right here because the tagging here does not correspond with the tagging in the frame. So how you can pass this traffic around it, you are going to have to come and put this interface. Oops. What did I just do? Okay, I can. Right here. So what you can do is to come and this interface you have here, you come and add this interface to VLAN 3. Add this interface to VLAN 3 right here. So that when the traffic from here hits this interface, the interface will check on the tag and see that it's VLAN 3. And the interface is also in VLAN 3. So it will allow the traffic to go over. And here on the end switch, the interface is also on VLAN 3. So once it sees that the tagging is VLAN 3, it will move this traffic to the interfaces that belong to VLAN 3 and decides by their MAC address which of the interfaces have it. So that is what will happen. But then we also have VLAN 2 plugged here. And we want VLAN 2 to be able to talk to VLAN 2. And you already, by the concept I explained, this guy is in VLAN 3. Once traffic that is tagged with VLAN 2 reaches here, and this guy is not configured to allow VLAN 3, it will drop the traffic right here because it's on VLAN 3. You are sending a traffic of VLAN 2, so this guy will not take it. So what you will do here is also to do what? You can plug another interface from here to here and tag it for VLAN 2. Tag it for VLAN 2. So once the traffic hits the interface, it will hit the VLAN 2 interface, and then it will take this route or this interface and go over to here, and the traffic will be moved to the interface that are on VLAN 2. The same thing you will do for VLAN 5. So this guy will be VLAN 5. Traffic going to VLAN 5 will also use this interface and use this guy. Now imagine in a way, I have seen environments where customer has about 20 VLANs. And they have multiple switches. And they have multiple VLANs plugged in multiple switches. So in this scenario, Simeon, tell me, what do you think the customer should do? Now they have here, this topology here have 3 VLANs, and we already have 3 VLANs here. So if this our switch have about 20 VLANs, based on this, what do you think we will do?
Okay. Those on that interface will be 20.
On which interface?
Hello? Okay. Come again, Ma. What is the question? Come again.
If we have VLANs plugged, maybe I have extra VLANs here. This is VLAN 5. I have up to from 5 to VLAN 20 plugged here. Maybe one person is VLAN 5, one person is VLAN 6, okay. VLAN 7, VLAN 8, and the same thing happens here. We have VLAN 7, I have VLAN 8 somewhere here, up to 20 VLANs in each of the switch. And we want the communication to flow between these switches. Understanding that by default, you need to assign the interfaces to a VLAN for it to be able to move the traffic between the switches. And we have 20 VLANs on the switches. What can we do?
Okay. Since we have 20 VLANs, that means the interfaces will have to be 22. So we need to create extra VLANs on the interface.
VLANs and add a connection to each of them to 20, Abby?
Yes, ma'am.
Good job. Good job. So we're going to create these 20 interfaces. Please tell me, where would you get these interfaces from?
Okay, from each of those VLANs.
Oh, no. These are physical ports. So these are physical ports on the switches. And maybe this switch is a 24-port switch. And you have 20 VLANs on the switch. Maybe one port is equal to 1 VLAN. So you are going to be using 20 ports already for the 20 computers that plug on each VLAN. Out of that, you have only 4 ports left. And you need 20 ports here.
I think we need to, since it is 20 ports that we have in each, which means per each VLANs, we'll be having, per each interfaces, we'll be having 5. Sorry, we have, I didn't, okay.
No, go ahead. I want to understand your point, your
Okay.
understanding of
Okay.
your perspective before
Okay,
we
what
go
I'm
to
saying,
things.
okay, what I'm saying is, okay, let's assume we have, just like you just wrote, VLAN 3, VLAN 2, VLAN 5, like the beginning of the diagram. Now, when we are not trying to communicate to the other switches, you created an interface that carries the VLAN interfaces, each of those VLAN 2, VLAN 3, VLAN 4. So if we have extra ports that are added to these VLANs, so at the interface going to the next switch, we'll be adding all those VLANs to those interface, which means we are still going to be having 3 VLANs here, VLAN 2, VLAN 3, VLAN, since they are all on the same VLANs. So you don't need to create extra 20 VLANs any longer, since they are all still on the same VLANs.
No, but then you cannot assign an interface cannot understand multiple VLANs. This is an access port. Access port can only be assigned to one VLAN. So when you connect it from here to here, it can only carry one VLAN. You cannot come and say, this guy take a VLAN 2, VLAN 3, and VLAN 10. This guy take VLAN 5 and VLAN 5 and VLAN maybe VLAN 15. It doesn't work. They are access ports. They only understand one VLAN.
Okay. We'll make use of the default VLANs then, since it's VLAN 1.
So if you make use of the default VLAN, it's only VLAN 1, which will only VLAN 1. So VLAN 1 interface access port to communicate with the other switch.
Ma, we didn't hear you clearly, ma.
If you say we use the default VLAN, which is VLAN 1, let me say this is VLAN 1, but it's also an access port. It can only carry VLAN 1 traffic. We don't even have VLAN 1 plugged here, so this guy will not be carrying any traffic, and we want to maintain our segmentation the way it is. So this guy will only understand traffic for that are tagged with VLAN ID 1. So by this solution, you need to find a way to have 20 ports connected to each of these switches to be able to carry 20 VLAN, which nobody does in a personal environment. Nobody will do that. So if you want to scale this, what we will do is delete all this. We don't want to be connecting the interface to VLAN. That does not scale. What we will do, we will have just a single connectivity, a single connection from here to here. And then this interface, we are not going to assign it to any VLAN. Here, we are not going to assign it to any VLAN. And we are not going to make it an access port. So we make it a special type of port, which we call a trunk port. It's called a trunk port. So what it will do is, with this single connectivity, you can allow this trunk port to carry traffic from any VLAN that you have. So this interface, it doesn't belong to any specific interface because you're going to trunk it. Trunking means I am not assigning you to any interface. So I'm not assigning you to any VLAN. I want you to understand and allow traffic from any VLAN going from this switch to the other switch. But you need to come and tell the trunk interface the VLANs that you want it to allow. By default, it will allow all VLANs that you configured on the switch to pass through from here to here. So now it doesn't belong to any specific VLAN, but it's going to understand all VLAN traffic that passes through it. So if traffic originating from VLAN 8 hit this interface is going to allow it to pass through, go to this switch and find the VLAN 8 this switch and then move the traffic over there. It is destined to there as well. If the tagging is for VLAN 3, the interface is going to allow it to go through. So as a trunk, The trunk will understand and allow any VLAN ID that you have configured for it to allow. By default, it's going to allow all VLAN to pass through it. So that is why we trunk it. Instead of having individual ports for individual VLAN, we can have one port, configure it as a trunk port, and let it recognize all the VLANs that you configure and pass the traffic through. So this one and having individual interfaces, which one do you think is still better? Timia, which one do you think is still better?
Huh?
With this kind of design, having a trunk interface and having individual interfaces for individual ports connected to the switches, which one do you think will scale better? Which one do you think reduces administrative overhead?
The single one.
The trunk ports. The trunk ports will always scale. So nobody does this in a production environment. This is what we do. We use one interface, put it in a trunk mode, and let it understand all traffic that passes through it. Does that answer your question, or does that provide more clarity?
It's clear, my yes, I understand why.
Can we continue?
Yes, ma'am.
All right. Feel free to ask your questions. Ask your questions before. Let me go back to my. I was bringing up. If you have a question, you're gonna ask her to. Don't type it on the chat because I'm not looking at the chat. Let me share this. My interface 1, interface 2. Okay. So let me continue with my packet tracer.
Hello, ma. Hello? Hello, can you hear me?
I can hear you. Go ahead.
So, okay, what if we have more than one? What if we have two switches, for instance, and
Yeah, we're gonna trunk all of them. I think it's part of what we're gonna do in this exercise because we have 3 switches. So
okay,
we
that's
have
fine.
multiple switches, and each of the switch are connecting to multiple VLANs. You're gonna trunk all the ports. So let me get my question out from here. Okay. And then I'll make this guy bigger. Okay, so let's go ahead. First of all, let me just copy this exercise and I'll put it somewhere on the screen so we can have it handy. So this is the problem we are going to deal with. I'm going to make it easy right here. So it says, first of all, create 4 VLANs on a single switch. So I'm going to bring one switch right here. But before I start breaking anything here, creating multiple VLANs, let's go into this switch and look at the VLAN configuration on this guy. The default VLAN config that comes with it. En show interface VLAN brief. Then it's okay, sorry, I don't think it's show VLAN brief. Yeah, right here. So this is the default VLAN details on this switch. I'm gonna put it here so you see it. This is the default VLAN details on this switch. You can see we have VLAN 1, which is default VLAN. And here you see that all the ports are part of VLAN 1. These are other default VLANs that I've never used in my entire life. I don't even know what these VLANs do, but they are there. So this one is right here. Our concern is the default VLAN. And for this default VLAN, you cannot change the name, you cannot delete it, and you cannot change the ID. Every interface is part of this VLAN. That is why all the computers that you connect by default on the switch belonging to the same network, they will communicate because they are in one VLAN. They are in the same VLAN. So from port 1 to port 24 and the gigabit ports, all of them are part of this default VLAN. So if I have this switch, if I have a computer plugged right here, I have another computer plugged right here. Let me get another one plugged in. Let me give this computer's IP from this range. And then we'll just try to communicate with them. But let me do cabling. I don't want to do auto cabling because I want to choose my own interfaces. So I'm going to connect this guy to 01. I'm going to connect this guy to 06. And I'm going to connect this guy to 011. So these three computers are connected to the same switch, and all of them are on the same VLAN, which is VLAN 1 before VLAN. Let me give them IP address from this range. And we're supposed to break this into 4, so we're going to break that later. So here I'm going to give this guy, what IP is that? 192.168.10. I'm going to give it .5. Subnet mask, we're going to leave it at /24 and leave it like that. And this guy, I'm going to give it 192.168.10. Let me give you, I'm breaking this into 4. So let me give this guy .66. Subnet mask is this different here, and this guy, I'm gonna give it 192.168.10. Break into 4. I'm gonna give this guy like 130. Subnet mask is the same. All right, so now I gave them IP addresses, and if I ping across them, they should communicate without a problem because they are on the same network, on the same VLAN. So these are the two requirements: the same network, the same VLAN. They will communicate by default. So we can see that these three computers are communicating. We have not done any configuration on the VLAN. Everything is still default over here. So they are all communicating. So let's go ahead and configure this VLAN. We say create 4 VLANs as below. We have sales, VLAN 10, HR, VLAN 20, IT, VLAN 30, and accounting, VLAN 40. I'm just going to type the command somewhere here and copy it into my suite. So I'm just going to go into config T mode, and then I'm going to do VLAN what? VLAN 10, and I'll give it a name. The name is sales. And then I'll do VLAN 20. The name is HR. And then I'll do VLAN 30. The name is IT. And then I do VLAN 40. The name is accounting. Okay. So that is the command I'm going to copy just here. I'm going to go into config T. I'm going to create the VLANs. First line is creating the VLAN. Second one is giving it a name. Create the VLAN, give it a name. Create the VLAN, give it a name. Create the VLAN, and give it a name. So I'm going to copy the command. Dude, why are you existing? Please don't tell me that thing deleted. Okay, right here. How does it do that? How is it doing that? Hi, I'm not gonna copy, I'm just gonna type. Okay, so I'm gonna go here. I wanted to copy the command, but I don't know what that interface is doing. So I'm just gonna type it out. So I have VLAN 10, give it a name. The name is sales. Then I create VLAN 20. The name is HR. I create VLAN 30. The name is IT. And then I create VLAN 40. The name is accounting. If I do show VLAN brief. So these are the VLANs I created right here. VLAN 10. You see, we don't have any interfaces attached to them, but at least we have them right here. We have the VLANs we created. VLAN 10, VLAN 20, VLAN 30, and VLAN 40, and you see they have a name. So the next thing is to assign these interfaces as they have asked us to do. So we're going to go and assign these interfaces right here. Right now, all the interfaces are part of VLAN 1. So, but we're going to move the interfaces to these VLANs and then we'll see. How did you open the CLI? To open the CLI, you just click on the device right here. I want to open the CLI for the switch. Just click on it. The default opening will be the CLI. If it doesn't open on CLI, then you can move to the CLI tab right here. You just click on the device and it will open. The default opening is on CLI, so you should be able to see it. Okay, so let's go ahead and assign our interfaces. Now, there are two ways you can assign the interfaces. You can assign them individually, or if the interfaces are sequential, you can bundle it up in a range of interface and assign them that, right? You can do it individually. So you go to interface 1, move it to VLAN 1, go to interface 2, move it to VLAN 10, go to interface 3, move it to VLAN 10. Or if they are sequential, like consistent following, right? 1, 2, 3, 4, you can bundle it up and do the configuration in them as a range of interfaces. So for the first one, we are going to do it individually, but for the rest of them, we're going to bundle it because it's faster. So let's go and assign these interfaces 01 to 05 to VLAN 10. So I'm going to go into interface F0/1 and then convert it to an access port first, switch port mode access, and then do switch port access VLAN 10 right here. So I'll move that to VLAN 10. If I go to interface F0/2, do the same thing, switch port mode access, switch port mode VLAN 10. Then I'll do interface F0/3, do the same, VLAN mode access, VLAN mode VLAN 10. Interface F0/4, do the same, make it an access port, and then move it to VLAN 10. The last interface F0/5, do the same thing, make it an access port, and then move it to VLAN 10. So if I do show VLAN brief, you will see you have these interfaces moved to the VLAN 10. And once you move into a new VLAN, it's going to leave the default VLAN. So now 0 to 5 is no longer part of the default VLAN because we have moved them to VLAN 10. So let's go ahead and move the rest of the interfaces. Now I'm going to move it in range. So it's easier for me to do it. Exit. So I'm going to do interface range. Interface range F0 slash. You're moving from /6 to 10. So you see the difference when it comes to here. It's telling me I'm an interface range. So I am in more than one interface right now. If I was on a single interface, I would just get config IF. But right now, I am in multiple interface. So I'm in config IF range. So whatever change I make here will affect interface 0/2 up to interface 0/10. So I'm going to do switch port
Elma,
mode. Go ahead.
but when you were doing the first 5 VLANs, so the first 5 interface, you didn't use interface range, right?
Yeah, because I was doing this thing. That's what I said. I'm doing it per interface, right? So you can do it on a single interface if you want to do one by one. But me, I want to bundle the whole interface as one because they are sequential. So whatever change I make here will affect interface 6 to 10. But I was doing it one when I did for this guy. So I'll show you guys there are 2 ways you can do it. You can choose to do it one after the other, one interface at a go, or you can bundle the interfaces up if they are sequential. Does that answer your question?
Yes, ma'am.
Okay. So now let me do switch port mode access, and then we do switch port access VLAN 20, right? Yeah, VLAN 20. So let's bundle the next interface. Now I have moved interface F to 10 to HR. Let's move the 11 to 15 to IT. So I'm going to do interface range F0/15 to 11 F0/11 to 15. Bundle it up, do switch port mode access, and then switch port access VLAN 30. So let me bundle the last one, interface range F0/16 to 20, right? Yeah. Switch port mode access, switch port access VLAN 40. So now I've moved the entire interfaces as described. So if I do show VLAN brief, do show VLAN brief. Okay, so you see they are now moved. All the VLANs now have interfaces on them right here. So from the topology I have, this interface now is part of, this was interface F0/1 is part of VLAN 10. This was F0/6 is part of VLAN 20. This was F0/11 is part of VLAN 30. So now they are no longer in the same VLAN. If I try to communicate across them, of course the communication will be failing because now they are on different VLANs. The IPs did not change. The only thing that changed was the port where they are plugged has been moved to another VLAN. So this, the switch, you see them now, they are connected to different VLANs. I'm sorry, guys, I cannot zoom into the screen, especially when I'm on the package tracer. It doesn't allow me to zoom the screen. On the CLI, this is the highest I can go. I can zoom the screen. It doesn't have option to increase the font. So I'm not able to increase the font.
They can actually zoom it from their own hand. You'll see it clearly.
From where?
Whoever uses, the user, you can zoom it from their own hand with their
Yeah, they
phone or
can
their
zoom
laptop.
from their own end, but I can't zoom myself. So you can zoom on your end, but I can't. This is the highest I can go. That is why sometimes I type it out in Notepad so that you see the command before I paste it or before I type it right here, because it doesn't let me to zoom into what you can see. I'm sorry about that. All right, so that is, now the IP did not change. The only thing that changed was where we plugged the interface, right? So now they won't be able to communicate until we have a proper routing across them for them to be able to communicate. All right, ask your question before we go into the next task. Ask your questions. So the next task says this. Add 2 more switches and connect the trunk as follows. So on switch 0 to switch 1, connect the G0/1 on both as trunk. Switch 1 to switch 2, connect this one as trunk and replicate the VLANs on all the switches. I hate having to replicate the VLAN by myself. But at this point, I've not done the TP, so I'm gonna do it. So now let's add the switches. We said extra 2 switches. So right here, and it says between switch 0 and switch 1, we need to connect G0/1 on both interfaces. So here, go from here, get G0/1, connect it to G0/1 here. And then from here, here, go to G0/2 on both ends. So that is what it asks us to do. Now, it says we should trunk these interfaces. Why do we need to trunk them? Because we need to replicate the VLANs on these devices. And if we are doing that, I just deleted those commands. And if you are doing that, it means we are going to plug computers to them. But before we do that, let us create this subnetting. Let's do this subnetting. Of course, I already know in my head how I'm going to break this, what will be their new subnet mask. So I'm just going to, what happened? Guys, one moment, just a moment. My line just disconnected. I don't know why it disconnected. Okay. So let's continue. The goal is for us to configure the VLANs into each of these devices. But let's go ahead and do that first. Let me type out that command and then I'll copy it and put on both VLANs. We're going to replicate the VLAN assignment and the VLAN ports into this guy. Now, it doesn't have to be on the same ports as those switches. You can have VLAN 1 on 0 to 5 here and have VLAN 1 on 16 to 20 on this switch and have it on port 16 to 11 to 16 here. So it doesn't have to be the same port mapping that you have on the switch here that you have also on this switch. It doesn't have to be the same mapping on the switches, right? But I'm going to keep the same mapping here for easy configuration. So let me do that. We're going to type it here and then I'm going to copy it and put it. Sorry, I think my last ended. I don't know why it ended. Oh, I know why I didn't respond on time here. So let me just do that. Copy the command for the VLAN. VLAN 10, the name was HR. Now. VLAN 10, the name was HR, right? So VLAN 10 was sales. And then I have VLAN 20, name is HR. Then I have VLAN 30, the name was IT. And then I have VLAN 40, the name was accounting. All right. Guys, I'm sorry, I don't know what happened. The live just ended, so I have to restart it again. So if you were here before, I'm sorry. I didn't disconnect. I don't know what happened. It disconnected me. So let's continue. I'm going to replicate the VLANs on the other side before we start the connectivity, just to make it easier for me. So here, did I do config T there? No config T. So I'm just going to do config T, and I'm going to paste the commands to create the VLAN right here. And then I'm going to paste the same command here to create the VLANs. Again, config T, paste it to create the VLAN. So if I do show VLAN bridge, yeah, we have the VLANs created on both switches. All right. Now let's go and do the subnetting first. So if I'm going to subnet this, and they say create 4 subnets out of this and assign a subnet to each department, we have 4 departments. So if I am subnetting this is what it will turn out to be. 4 networks, subnet 1/24 created into 4 networks. I'm going to be having so I'm going to be borrowing 2 bits, and if I borrow 2 bits, that is /26, and /26 is 192. All right, so I'm going to be having 192.168, 192.168.10.0/26, and 192.168.10.64/26, and 192.168.10.128/26, and the last network will be 192.168.10.192/26. So this will be the 4 subnets if you have to break this guy down. So let's say the first one will be the HR, or the first network will be for sales. The second network will be for HR. The third network will be for IT. And the last network will be for accounting. All right. So this will be our subnet that we create from here. Now we're going to assign them to this. But before then, let us connect computers to these interfaces. The same way we trunk this guy, let's go ahead and assign the interface. I want to be able to, before I trunk the interfaces first, I want to connect my interfaces, my computers, and we'll try the connectivity first before we trunk this port, so that you see why the trunking, what the behavior of the trunking and what it's doing for us. So let me go ahead and do the port assignment to this. Assign the ports just the same way we have it here. Sales, 5021, HR, and all that. So let's go and do the port assignment on both switches. So right here, exit. I'm going to bundle all of them up so it's easier for me to do it. Or I can type it out so that I can copy it, because I'm going to be pasting it on the other switch as well. So if I have a interface range F0/1 to 5, do switch port, and I'm tapping, thinking I am here. You know what? Let me just go ahead and type it directly. Let me type it directly on the switch. So I have interface range F0/1 to 5, bundle it up, switch port, mode, access. This one we were going to assign to switch port access VLAN 10. And then I bundle the next one, interface range F0/6 to 10, switch port mode access, to switch port access VLAN 20. Then the other one I do, what other one? Interface range F0/11 to 15, switch port mode access, switch port access VLAN 30. Then the other one, the last one, interface range. Interface range F0/16 to 20. Switch port mode access. Switch port access VLAN 40. So if I do show VLAN brief, we'll see we have moved the interfaces to the right VLAN. So let's do the same thing on this other switch. Here we created the VLAN, so we're going to move the interfaces. Interface range F0/1 to 5. Switch port mode access. Switch port access VLAN 10. On to the next one, interface range F0/6 to 10. Switch port mode access. Switch port access VLAN 20. On to the next one, interface range F0/11 to 15. Switch port mode access. Switch port access VLAN 30. Then the last one, interface range. Hey brother, welcome in. How are you doing? Switch port range F0/16 to 20. Switch port mode access. Switch port access VLAN 40. Okay. Do show VLAN brief. There we go. So all interfaces have been assigned to this guy. Let's plug a computer to each interface. Let me have one computer here, one computer here, one computer here, one computer here. So we are going to group these guys, right? Let me add one extra computer here. Let me have one extra computer on this guy. I'm going to put this guy on the last VLAN, which will be somewhere from 16 over here. Okay. So now this guy here, this is VLAN 1, VLAN 2, VLAN 3, VLAN 4. So we're going to plug this guy VLAN 1, VLAN 2, VLAN 3, VLAN 4 on each of these switches. Just so we replicate them on both switches. So I'm going to do the connectivity. VLAN 1 is somewhere here, so type this. VLAN 2 is anything from 6 to 10, so I'm going to plug it on 7. Then on this guy, VLAN 3 will be anything on 11 to 15, which I will do 13 here. And VLAN 4 will be anything from 16 to 20, which I will do 18 here. So these computers are on different VLANs. These computers are on different VLANs. Oh, my leg. Okay, let's try to assign them the IP addresses to their ranges. This is the IP address we have. This is VLAN 1, VLAN 2, VLAN 3, VLAN 4, VLAN 1, VLAN 2, VLAN 3, VLAN 4. So let's give them IP addresses according to their VLANs. So here, you already gave these guys IP, because I intentionally gave them IPs according to their VLANs. This guy have 130, which is VLAN 3. This guy has 66, which falls in VLAN 2. This guy has 5, which falls on VLAN 1 and 2. So let's give this guy IP from accounting. 192.168. And let's give it 195. 195 falls on that VLAN, right? Yeah. And let's also correct the subnet mask, since we are no longer using all of them. So let's put them on the right subnet mask, which is .192/26. So we're going to go into these computers and change them to the same one, 192. So they reflect the right network. 192. Remember, I'm not giving them gateways yet, so I'm just giving them IP and subnet mask. IP and subnet mask. All right. So let's give these 4 computers, IPs. This one is from VLAN 1. So we're going to give it 192.168.10, but let's give it .10. Subnet mask is the same. And this guy, I'm going to give it 192.168.10 from VLAN 2. 70 should be part of VLAN 2. And this guy will be on VLAN 3, which I will give 192.168.10.135 to be part of VLAN 3. And then this guy I will give 192.168.10.200 should be part of VLAN 4 or VLAN 4. Yeah, VLAN 40. So this is 10, 20, 30, 40. 10, 20, 30, 40. All right. So now we have all the computers with the right IP address from their VLANs plugged into the right interfaces from their VLANs. So what we'll do now is to try to communicate across. This is VLAN 1. This is VLAN 10, which is on sales. To be able to talk to this guy on VLAN 10, which is also on sales. On sales VLAN. So let's see if they're able to communicate, which of course they will not communicate. Over here, I will ping 192.168.10. I get it .10. So they won't, even though they are on the same VLAN, but they are on different switch, and they won't be able to communicate. That is because that communication right now is dropped on this switch interface. Is dropped on this switch interface because this connectivity between switch 0 and switch 1, that connectivity belongs to VLAN 1, which is the default VLAN. This is V0/1. If I go here and look at the interface assignment for V0/1, you see it's still part of VLAN 1. So that interface will only understand traffic that is going through VLAN 1. Now let's move this interface here to VLAN 10 and see if they will communicate here. Let me move this interface to VLAN 10, this G0/1. I'm going to move it to VLAN 10. Here, config T, go to interface G0/1, switch port, mode, access, switch port, access, VLAN 10. Okay. And then on the pair switch, here I also move this one to VLAN 10 as well. Just for testing, I'm going to take that out because that doesn't scale. Interface G0/1, do switch port, mode, access, switch port, access, VLAN 10. Okay. So both interfaces are now on VLAN 10. Let's wait for it to come up and we'll try the ping again and see. We are trying to ping PC0 and PC3, which belongs to the same VLAN. Both of them are part of VLAN 10. And we have put this switch connectivity in VLAN 10 as well. So let's wait for it to come up and we'll try to ping it across again and see if it responds. Let me start the ping. From here to here, I'm going to ping this again. Now you see we are getting a response back. Now you see we are getting the response back from both of them. They are pinging now, they're able to reach each other because they are on the same VLAN. But that is not the same for if I want to ping from this VLAN 2 to this VLAN 1. Of course, it's not going to go through. This guy is this is VLAN 20 down here. This is VLAN 10. So let me ping .70 that belongs to a different VLAN. .70 will not respond to me because this interface has been configured to be part of VLAN 10 alone. So it will only carry traffic going to VLAN 10. So that means for us to get VLAN 20 to work here, we need to come and do another connectivity here. We need to come and do another connectivity here, maybe do G02 and G1 here or whatever it is. And this interface now, put it on VLAN 20 so that it will recognize traffic on VLAN 20. But nobody does this in production environment because it means I will have to do 4 cabling. It means I will have to do 4 cabling for each of my VLANs. Right here, cable again, for each of them will not carry individual traffic for the individual VLAN. And I'll come and do the same for these guys again. Do the cabling here for one VLAN, for the second VLAN, for the third VLAN. So if I have 20 routers or 20 switches, I'll come and do this for each of the VLANs. Who wants to be doing this? Certainly not me. I don't want to be doing this. So this is one way you do the routing, it's not even routing, connectivity between to allow to intra-VLAN communication. To allow for intra-VLAN communication within the same VLAN. So there have to be an interface on the switch that will be able to let you go. And you know the worst part of this is that if you do it like this, right, STP will not even let you because you see one of the ports here will always be in block mode. So STP will not even bring up all these ports for them to be in forwarding mode. So nobody will even do this in a person number because STP will not let you do this. Unless if I bundle these interfaces as part of an aggregate interface, then it can work. But as they are here now, individual interfaces, one of them must always stay in blocking mode because of STP. So nobody will do this in a production environment. I'm going to go ahead and delete this. Don't ask me what is STP. I don't want to go into STP right now. So I'm going to delete all this because it's not going to work. What we need to do is to trunk the interface. Put the interface in a trunk mode instead of putting it in a specific VLAN mode. So we put this interface, we trunk it, we come and trunk this one as well. And then we test the connectivity between VLANs and see if they work. Ask your question before we get into that. Cyber, welcome in, brother. How are you doing? Happy weekend. Ask your question before we go into trunking those interfaces. You got no questions? Okay. So let's go ahead and trunk the interfaces. Looking for my listing. So we're going to take the interface out of VLAN 10 that we plugged it, and we're going to go ahead and trunk the interface. Okay. It's just a one-line command there. On this switch, we are trunking just this interface. So I'm going to go to that interface. I think I'm still inside the interface right now. I'm on G0/1. So instead of leaving it in VLAN 10, I'm going to go ahead and put it in a trunk mode. And it's just a one-line command, switch port, mode, trunk. There you go. That's all I need to do. Then I go on this switch 1, this interface, G0/1 and G0/2. The two interfaces, I'm going to trunk them because they're connected to switches. So I'm going to put them in trunk mode. Or that is coming down, not the video error. So I'm going to bundle it together. Interface range, G0/1 to 2. Put it in switch port, mode, trunk. There you go. And then for this guy, switch 2, this interface, I'm going to trunk it as well. So go here, EN, config T, go to interface G0/2, switch port, mode, trunk. Okay, there we go. Let's wait for STP to finish its work and bring up the interfaces. And we're going to try intra-VLAN communication. That is communication between the same VLAN. Okay, this guy is up. So if I bring VLAN 10 and VLAN 10, it should communicate. even if they're on different switches. So this is VLAN 10, this is VLAN 10, this is VLAN 20, this is VLAN 20, this is VLAN 30, this is VLAN 30, and this is VLAN 40, this is VLAN 40. So intra-VLAN should communicate across the switches. Think from here to here, it was success. If I think from here to here, let me think it again. From here to here, why is that one failing? Didn't I trunk the interface? I'll get to that again. Let me confirm that this is the right interface. This 07 and this guy is, oh, okay, this guy is in VLAN 3. This is the VLAN 20 here. Yeah, this is VLAN 20. This guy is on VLAN 30. So let me change the IP addresses. Why did I even do that? I could have just moved them on a different interface instead of changing the IP. Let me move them on different interfaces then. Can't delete anything, just I know what, let me just change the IP. I don't want to be doing recabling. But it's fine, it was a mistake on my part. Let me just recable it. So this guy, I will plug it on VLAN 20, which is, put it on 7, and then this guy I will put on 11, which is VLAN 3. Okay, let the two come up, but let's test the last VLAN. This is VLAN 40, and this computer here will also be VLAN 40. Yeah. So let's try to ping from here to here, and this guy succeeded. So intra-VLAN is working. Computers plugged to the same VLAN, they will work right now because it doesn't matter if they're on the same switch or if they're on different switches because we have trunked the switch interfaces. Now this guy will be on VLAN 20 and this guy will be on VLAN 20. They should be able to communicate from here to here is also success. And then from VLAN 30 from here to here is also a success. So it doesn't matter the switch where the computers are plugged, as long as they are on the same VLAN, on the same IP subnet, they should be able to communicate if your trunk is properly configured on the switches. We already know that the inter-VLAN communication will not work because it's just like you plugging computers on different switches, on different networks. You're going to need to configure routing for them to be able to work. You're going to need a layer 3 device to be plugged in for them to be able to communicate for inter-VLAN routing. So for this, up to this extent, ask your question. Ask your question. Layer 3 Niger, or is it exactly? I don't know what that means. Thank you so much. Ask your questions, please. Up to this extent, ask your questions. You guys got no question? Ask me your question now. Okay? So let's go ahead and introduce routing here. We want all the VLANs to communicate. Right? We want all the VLANs to communicate. That is what we want to do now. So we want, this is VLAN 10, VLAN 20, VLAN 30, VLAN 40. So we want all these VLANs to be able to communicate with each other. Right now, we've achieved actually everything that is said here. We've done all this lab. Because add 2 more switches and then replicate the VLAN, confirm connectivity between the VLANs. So we are done with whatever is here. I'm going to go ahead and delete this guy. before we go into routing these guys out. No questions? I should continue? Okay, I'm continuing. So now we're going to talk about routing VLANs. There are different ways you can route your VLANs. We have about 3 of them, right? We have the direct interface routing, we have the router on a stick, and then we have the switch virtual interface, which is SVI. These are the 3 ways you can do inter-VLAN routing in your environment. That means allow routing between the devices. Any of them that you're using, one thing is common here. We need a layer 3 device in this network. We need a layer 3 device to come here and do routing for us. So if you're doing direct routing, direct interface routing, which does not scale in production environment, it's just like the same way we do, you have your router, you plug your switches on it. Let me grab my board. Let's explain that. I'm going to just explain. I'm not going to be building it because nobody does that these days. I'm just going to explain to you the two that we have. I think next week we will do SBI, but for today, let's look at the 2 types of routing that we can do. Let me move to my board. Okay. Go for yes. Okay. Can you see my board now? Please confirm if you can see my board.
Yes, ma'am, you can see your board.
Okay. So the first one, we have the 2 we are going to look at now. We are going to be implementing just one of them, but I need you to know that is also an option that you have, even though it does not scale in a production environment. Nobody does that. The first one is the direct interface routing or direct VLAN routing, however you want to call it. And the next one is router on a stick. It's also a part of VLAN routing. The next option is SVI, switch virtual interface. So any of these you implement, you will get the inter-VLAN to communicate. This, nobody does it in production environment, but I'm going to show you what it means. This depends on what you have, depends on the equipment that you have. So 99% of time, you will see this. Because this one, you just need one router. This guy doesn't need a router, you need a layer 3 switch to achieve SVI. You will see SVI more when you are building a 3-tier architecture or even a 2-tier architecture, where you have your access layer, have your distribution layer, and have your edge layer, all that. That's why you mostly see SVI being implemented. But if you don't have a layer 3 switch to do enterprise topology, you can always fall back to router on a stick, which is what will be what you will see most of the time. Someone say I'm echoing. I'm sorry, I can't help it. Where I am right now, that is all I can get. I'm not at home, so where I am right now may be echoing, but I can't help it. I'm sorry. So let's look at the direct VLAN routing. We have the switch, yeah, and we have another switch. I'm just going to do 2 switches here. And then these switches, we have VLANs connected to it. Maybe 4 VLANs, and here we have also 4 VLANs connected to it. Leave this guy. have the 4 VLANs here. These are different VLANs, VLAN 1, VLAN 2, VLAN 3, VLAN 4. VLAN 1, VLAN 2, VLAN 3, VLAN 4. If you trunk this interface, VLAN 1 here will communicate with VLAN 1 here. VLAN 2 here will communicate with VLAN 2 here. VLAN 3 here will communicate with VLAN 3 here. And VLAN 4 here will communicate with VLAN 4 here. But VLAN 1 cannot communicate to VLAN 2. VLAN 2 cannot communicate to VLAN 3. So inter-VLAN is not going to work. Not going to work. So for us to get inter-VLAN routing, we need to implement one of these. Let's look at the direct VLAN routing. For these two and these two, we need a router. So I'm going to introduce a router here. Direct VLAN routing means you have an interface from here to here, another interface, another interface, and another interface. Each of the interface will control each individual VLAN. This guy will put this interface on VLAN 1, put this interface on VLAN 2, put the interface on VLAN 3, and put the interface on VLAN 4. And then you give the interfaces here IP addresses from the IP subnet of VLAN 1, IP subnet of VLAN 2, IP subnet of here, and IP subnet of here. Just give these interfaces IP address based on the subnet IP. Assign the computers connected to these the appropriate default gateway and communication starts. So here, you just need to make sure the interfaces individually are connected to or assigned to each VLAN. And then on the router side, you don't need to trunk. You don't trunk anything on the router side. You just trunk on the switch side. Sorry, I'm not even talking about trunking. You don't tag the interfaces on the router side, meaning you don't assign them to a VLAN. You just assign them a VLAN on the switch side, assign them IP address on the router side. The IP address you assign on the router side, assign it to the computers as their various default gateways, and you will have your inter-VLAN routing communication working. This is your direct VLAN routing. So if you have 20 VLANs in your environment, you need to be spinning up individual interfaces or here and there, mapping it here. So each of them will have a connectivity to the router for you to be able to do that. So this is your normal direct VLAN routing. The disadvantage in this is where are you going to get that interface on the router side for you to do this? The router interface is very precious and it's very, very small, right? It's for you to get a router that has up to 10 interfaces on it. You know how much you're going to spend to do that. So router interfaces are very precious. We only use them as needed. If need be, if there is any other alternative for us to preserve the router interface, we will take it. So that is why this guy does not scale anywhere. Because for each VLAN you have, you need to spin up an interface on the router for that VLAN for it to be able to communicate across. So this doesn't scale because number one, is not cost effective. Number two, it increases your administrative overhead because each of them you need to manage both on the switch side and on the router side. So this does not scale in the personal environment. That is why you will never see this configured anywhere. I'm not going to be the first to configure it for you. You can try it out on your own, your lab environment, and see how it works. It will still work perfectly fine. It's just that, how are you going to control the router interfaces if you don't have? You already see that by default, most of the routers here have only 2 interfaces. So if you're going to be doing this, where are you going to get all these interfaces from? In a production environment, for companies to buy a router that has this amount of interface. Maybe they're using a third-party transceivers, SFPs, in their devices. They're going to be considering how many ports that SFP have. And the more ports your SFP have, the more money it costs. And also, depending on the speed of the SFP that you have as well. But the goal is that it's very expensive to get these ports available on your router. So that is why you will hardly see this in a production environment. Ask your questions. Ask your questions.
But is it only on router we make use of the SFPs? What about switch?
No, switches have SFP. You can buy SFP for your switch. SFP is a module that you plug on your device. But you know, the more bandwidth or the more speed of your SFP, the more ports your SFP have, the more ports. So you can buy your SFP anywhere. Your firewall, not a firewall. Even your firewall as well can support SFP as long as your vendor supports that third-party SFP. You can use it, or you can ask your vendor to send you a supported SFP for you to use on your devices. Question. Okay, so let's go ahead and do away with this that does not work. This is for direct routing. I'm going to delete this and do what actually works. Fine, I'll delete it all. Now, the next one, which is the one we're going to be implementing in router on XT. I'm still asking who came up with that name, but who am I? So you have a router here, just one router, and you have an interface on the switch. It doesn't matter which of the switch you are plugging your router to. You can plug your router to this switch. You can plug it to any of the switch. So any of them is fine. Depends on your organizational need, or maybe many organizations may have routers of different capacity, or the one that they want to use specifically, maybe is their BTP server, and they want to use it to connect to the router. But it doesn't matter which of them you use. You can use this router, you can use this switch, you can use this switch. So I'm going to connect. All we need for router on the stick is just a simple interface. One interface is all that we need. Then that one interface on the router side, on the switch side, we are going to trunk it. You already know that when we trunk an interface, it carries multiple VLANs. Then on here, we trunk the interface. On the router side, we spin up what we call sub-interfaces. Is virtual interfaces out of this main interface. I'll take it again. On the switch side, we will trunk the interface. On the router interface, on the router side, we do not assign IP to this interface itself. The only thing we need to make sure is that the interface is up and running. Then out of this interface, we are going to create sub-interfaces. It's like a virtual interface that you don't see, but you're creating it out of this interface. So it's going to be like a virtual interface from here to here. Depending on how many VLANs you have. We have 4 VLANs, so we're going to create 4 virtual interfaces. These are virtual. We're not going to be doing this connectivity. All of them are dependent on this physical interface. If this interface goes down, this physical interface goes down, all your sub-interfaces goes down. So it's going to be relying on the connectivity of the physical interface, and then you spin up the sub-interfaces. When you spin them up, you will now tag the individual sub-interfaces with the 802.12 encapsulation, and then tag it to a specific VLAN. The subinterface you spin up, you're going to encapsulate it with 802.1q protocol, which is the VLAN IEEE protocol, 802.1q, and then tag it with a specific VLAN ID. We have 4 subinterfaces we're going to create. So each of them, we're going to tag them with a specific VLAN ID. Maybe this one is for 1, this one is for 2, this one is for 3, this one is for 4. And then you now assign IP addresses to the subinterface. If you do not encapsulate the interfaces first, you won't be able to assign IP address to them. So you need to first of all encapsulate the interfaces, and then you can assign IP. The subinterfaces will now serve as the default gateway for each of the VLANs that you have. The subinterfaces will now serve as a default gateway for the VLANs that you have after you've tagged them in the specific VLAN. And the VLAN ID you're tagging them with must match the VLAN ID that you have created already, that this trunk interface will be carrying. So this trunk interface will be carrying VLAN 1, 2, 3, 4. You are going to be encapsulating 4 different subinterfaces with ID 1, 2, 3, 4. Ask your questions. Ask your questions. Okay, let's go ahead and implement that in our lab. I'm going to disconnect my board. All right, let me move back to one, two, three. Okay. I think I have a slide for that. Let me see. Okay, right here, router on a stick. That's what it's called. So we say we use router on a stick to configure routing between VLANs using one router interface. We already explained this. So routes is also known as the inter-VLAN routing. We also mentioned this. It requires creating a sub-interface on the router that is based on a single physical interface. Now, how do you create the sub-interface? Select one of the physical interfaces and bring it up. So make sure the interface is off, but do not assign this interface an IP address. Then create a sub-interface out of the physical interface. Encapsulate the sub-interface with 802.1q and the VLAN number or VLAN ID. Assign IP address to the sub-interface as the default gateway for each VLAN. On the switch side, the interface connected to the router interface must be configured as a trunk to enable it carry multiple VLANs. Now, how do you create a sub-interface? It's a simple command. You need to, remember we say this is based on a physical interface. So you're creating it out of a physical interface. So in this example, we are creating it out of interface F0/0. So interface F0/0.1. Once you put dot something, the system understands that you're creating a sub-interface. For easy identification, I usually like to name my sub-interface with the right ID VLAN. So if I'm creating for VLAN 40, I'm going to do interface V0/1.40. If I'm creating for VLAN 20, interface F0/0.20. That way, you also keep identifying those interfaces and the router and the VLAN they represent easily. And then this is you tagging it with 802.1q. Encapsulation.1q2. These two here represent the VLAN ID, which in our case, we're going to be doing 1040, 1030, 1020, 30, 40 here. That's your VLAN number. And then you can assign it an IP address. That's what you have to do. So it's like a 3 command. First of all, or 4 commands, I would say. First of all, you bring up the physical interface, make sure it's in up state. Because if the interface is down, you will be able to create the sub-interface, but the sub-interface will also be down. So your physical interface needs to be in up state. And then you enter the command fa0/2 dot whatever VLAN ID you want to use. And then you encapsulate it with the right .1q VLAN number and assign IP address. So let's go ahead and do that in our lab. If you have a question, please ask before we finish designing. So here I'm going to bring up one router 2900 right here. And we are going to be assigning the sub-interfaces, the first available IP of each network. That's what we're going to be assigning them as the gateway. So I'm going to grab the interface here. On the router, on the switch, I'm going to use this gigabit interface. And on the router, I'm going to use the same interface number, G0/1. On the switch side, I'm going to trunk this interface. Let me go ahead and trunk it. What interface is that? G0/1. So here, I'm going to trunk that interface. EN config T interface G0/1 issue switch port mode trunk. Okay. That's all I do on the switch side. Then on the router side is where I create most of those. So I go here. Let me see if I can type this out in the notepad. So that just you guys can see it better. So here I'm going to, let me include this one. So on that interface, I'm going to go to interface G0/1. I'm going to issue no short to bring the interface up. And then I'm going to start creating my sub-interfaces out of it. I'm going to do interface G0/1.40 for .10. Then I'm going to encapsulate it, encapsulate 801.1q, 802.1q. I'm going to get this command from the system later. And then the ID number for your VLAN, which is VLAN 10. And then you give it an IP address. For this first one, the IP I'm going to give you the IP add 192.168.10.1 because this will serve for the sales department and their network is 192.168.10.26. So I'm going to give them the first available IP of each of the networks. And subnet mask is 255.255.255.192. Then that is it about the first one. Then you create the second one, interface G0/1.20. You encapsulate it with I think it's just .1q is the command. .1q20. Encapsulate .1q20 and then give it IP. IP add 192.168.10. The first available IP on the second network is 65. 255.255.255.192. That's it. The third interface G0/1.30, encapsulate it with .1 key on the interface number, VLAN number, VLAN 30, and then assign IP add 192.168.10.129, 255.255.255.0. That's it. Then the last one, interface G0/1.40, encapsulated in tab.1Q 40. Assign IP add 192.168.10.193, 255.255.255.192. All right, so this is the commands that we are going to be typing. The first thing we do again is to bring up the interface, which is no short, and then we'll create the 4 interfaces out of the physical interface. So let's go ahead. I'm not going to copy this because I'm not sure I got this command right, but it's something related to that. But let me see. So from here, there is a new router. If I do here and do show interface, show IP interface brief, you see everything is down. We only have 3 interfaces here. So we are going to bring up the G0/1. Go inside the interface G0/1. Sorry, do config interface G0/1 issue no shorts. Bring it up. Now it's up. So let's go ahead and configure or spin up the sub interfaces. So it's gonna be interface G0/1.10. Do encapsulation .1Q. Yeah, it does .1Q10. And then give it IP add. This guy I'm giving it 192.168.10.1, 255.255.255.192. Spin up the second one, .20. Do encapsulation for 20, and then assign IP address. The IP I'm giving this guy is 65, right? Yeah, that's it. Then the third one, interface G0/1.30, encapsulate it with .30, and then assign IP address. The IP I'm giving this guy is 129. The last one, interface G0/1.40, encapsulate it with .40, and then assign IP. I'm assigning .193 here. Very good. Do show IP interface brief. So we see our sub interfaces have been created. These are our sub interfaces. And you see they all have IP. And we created it out of the G0/1. You see it is up, but you see there's no IP assigned. You can assign it an IP address. So you generate your sub interface out of it. All we need to make sure is that it is in the up state. The status is up, and then you assign your IPs to them. If I look at the routing protocol, the routing table of this guy, you will see that it will be pointing to the sub interfaces that we created. Do show IP routes. There you go. So it's not pointing anything to the physical interface. Everything is being pointed to the sub interface that we created. This is the route table. Yeah. So you see the networks are pointing to the sub interfaces, not to the physical interfaces that we created. And you can actually read all those. Did I miss something? No, I didn't copy everything. So you see, everything is pointing to that. So moment of truth, let's try to test our communication now, inter-VLAN communication. I'm going to think from VLAN 1, VLAN 10 to VLAN 20. The first one I expect to fail, but the second one should not try me. The second one is still trying me. Testing again. Okay, now it's time to trouble. Did I miss something? Let me see if it's not responding. That's 70. Let's see why it's not responding. Did we miss something? It's sending, but nothing is coming back. And I shrunk that interface. Okay, let's troubleshoot. But let's try other ones, see if other ones are responding. So that we'll know where to limit our troubleshooting to. So this guy communicates to this guy. Communicate again. Not working. Communicate again. Still not working. Okay. So let's troubleshoot, guys. I don't know why, but let's see why it's not working. Did I miss something? Let's delete this. Start our capture and think from here to here. Let's. Oh, my bad. It was dropped on the computer itself because it doesn't have a gateway. So let's assign the computer as a gateway. 192.168.10.1. So see, immediately I did the capture, it failed on the computer itself. So I knew it was something on the computer itself. It didn't even need the computer at all. So we're going to give all the computers the correct subnet default gateway. This guy will have 65. And this one is for network VLAN 3, VLAN 30, which will have wait, this guy is on VLAN 3. Yeah, which will be 129. And then this one will be on 193. Okay, let's try this guy. This one is also .1. And this one will be .65. This guy will be .129. Huh? Yeah, 129. And this guy will be on 193. All right. So everybody got a gateway. Let's try again. From here to here. First one expected to fail. Okay, second one succeeded. So the communication is now going to succeeded. Try the third one from here to here. Bring it again from here to here and succeeded. So we are able to communicate between the VLANs. If I think from here to here, bring it again from here to here, it succeeds. If I think from here to here, it also succeeds. So we have just enabled inter-VLAN routing between these devices. All right, so everybody's communicating now. Thanks to our router honesty. Go ahead and ask your question, please. Oh. Ask your questions, and that is how you set up VLAN between devices and also introduce inter-VLAN routing. between them. This is what you will see in most production environments. Unless if the organization have a layer 3 switch, they can leverage SVI. So we're going to look at SVI next week, how you can use SVI. In fact, next week, I will see if we can actually build a full 3-tier architecture topology, where we have the asset, the division, and the core. So you see what is expected or what you can see in most production environments. Ask your questions, please, before we round up. Questions? If no question, I'm going to stop recording. Hopefully, I'm still recording.